It's Bashir Electric once more. So this is a star delta circuit diagram. We did it in part 1. So today we are going to see how to implement this circuit diagram into real wiring using the real components. So I shall not delay, let's dive into the wiring. We are going to use Cade simulation software as usual. I'm going to create a new file. So I'm going to have my power supplies. We are going to have a star delta connection wiring. So I'm going to have my circuit breaker, let me have a 4-pole, so I'm going to have my circuit breaker, then we are going to have 3 contactors. Then we are going to have 1 overload, then we are going to have a star delta motor. Let me align them properly and create some good space. Let me align my contactors. So I'm going to do the cabling as usual. So I think, yeah, that one for the first time I can give it like that. So I'm going to have here line 1, then line 2, then line 3, then this one is a short circuit, then I'm going to have this one up to here, line 2, then line 3. Now here will be critical. Allow me zoom a bit so that we can analyze this one properly. So this is line 1. When we reach, this is line 3. Line 3 is connecting with W1. So here it's going to come and connect with V. So line 2 is connecting here with V. Here we are going to give it U. Then this one is connecting with W, like that. So on the control, I'm going just to have 3 buttons. I'm going to have an emergency, I'm going to have a stop, I'm going to have a start. So I configure this one to give me an emergency, I configure this one to give me a stop, and this one will remain a start. Then maybe we shall add on indicator lamps with time. So now I'm going to get my power from, I think I can get from line 1. I'm going to get power from line 1. Then take it to emergency, just because I don't have here some 2-pole or 1-pole breaker, but I would have used it as a control breaker. So this one is a joint here. So from there I'm going to come to the stop, then from there I'm going to give it the start. Remember, the start we use the open line, and from there we are going to give it the main contactor. So I think I can fetch it from here. I want to try to look a bit neat. Then I'm going to slope. I think something like that. Then also we need what we call the retaining power, that is the self-holding power. I'm going to get it from either pin 2 or pin 3, around there. Then I give it to the normal open of the main contactor, that is 13 and 14. Then from there I'm going to give it the coil. So I can already get here from 13, which is the normal open. Then I give it to the coil. That one is a joint around there. Then that means I have to get the power and feed it to 14, which is around. Then I come, then I get it from pin 2. So that is the self-holding. So in a star and delta we need something called a timer. So when I add a timer, my timer is here. Allow me put it around here. So this timer, when I check for its symbol, you'll find that when I zoom it a bit, you'll find that 13 and 14, they are coils. Then I think I'm going to use one set of line. I'm going to use one. Let me see the one which is nearer, 4, 8 and 12. So we have 12 is the common, which is here. Then it is normally closed with 4 and normally open with 8. So 12 is closed with 4 and open with 8. So those are the lines that we are going to use to feed our star and delta contactors accordingly. So when I take it back to image, but I can first leave it in symbol for recognition during wiring. So here we are going to also at the same time power the timer, which is 13 and 14. So we are going to power it like that. Have here our connection. Then the 13 we shall give it neutral when we reach to routing the neutral. So from there, that very power we are going to loop it to pin 12. Pin 12. Then that means from 4 it is going to give the star, since it is the star first. Then from 8 is going to give delta, but we shall first employ the interlock mechanism. So to employ the interlock, we shall have from the normally closed of this one, which is 21, it's going to give this one. From the normally closed of delta, it's going to give the star, and also from the normally closed of the star, it's going to give the delta. So that is interlock. So now these pins are the ones which are going to be receiving from the timer. So we have from 4 normally closed is going to come to the delta, and the delta, I mean to the star, and the star is receiving from here. So from 4, so you see here there is no dot, which means the wires are just crossing, they are not connecting to each other. Then from 8, which is this way, is going to give the delta, and the delta is receiving from here. It is from here, the normally closed, then it comes and feeds the delta here. So it's going to get from around here. Let me follow the same route for neatness. So that is powering the delta from the normally open through the normally closed of the star to go and power the delta. Hope we are all together. So what is remaining, it is giving our components the neutral line, and for this case we shall first pass our neutral through the overload for protection. So I'm going to have here the neutral cable from 96 is going to come and the power A2 here. It is going to give the same A2 here. It is a dot. Then from here it's also going to power another A2 here. Then from there it's also going to power the timer. I mean it's going to complete the timer. And that is 13. Yeah, like that. So here it is now from here 95, which is the normally closed, to our circuit breaker, to the neutral of our circuit breaker, which is here. So I think that is 5 seconds. So and take back this symbol to our image. That is how it looks like. So we do the simulation again. It is this delta, I mean main with the star. After, then it is now main with the delta. The time is counting from here. Let me show you. Start. The time is 4, 3, 2. It is counting from here. So once it reaches to 0, it switches off the star and switches on the delta. So thanks for watching. See you when you see me in the next tutorials.